In our chapter on experimental design, we looked at the dog blocking example where we said, okay, which treatment works best, calcium, exercise, or maybe neither of those work well. And here we can see I did a complete randomized design to randomly assign the treatments to the pets. I did what's called scrambling the attribute, so you can do scramble attribute values. And when I did that, this is what I got. You can see that these are all scrambled. We've got the name of the dog, the change based on the breed, the average bone density change that we'd expect to see for any dog in general, the change based on the kennel, other random factors that we can't control for, and the change based on the treatment. And then what I did here is I created an attribute called total, where I took the change in the breed and the kennel and the other and the change by treatment, and I recorded those. And then over here I said, okay, normally we'd expect on average there to be 105, negative 105 for the bone density change. How far off are we from that? Was the change more than 105 points lower or less than 105 points lower? So here we can see the differences, and this is the treatment. So -8 was for control, 6 was for exercise, a change of 2 for calcium, and so on. So I actually had to go and type this in based on what was randomly assigned for the treatment, just so that when I graphed it down here I could see the separate treatment categories, calcium, control, and exercise. And when we take a look at this, we can see that there's not really much of a difference here. I mean, these are all pretty much centered at 0. Sometimes calcium was worse, sometimes it was better. Sometimes exercise was better, sometimes it was worse, and the control is also all over the place. So then we decided to block by dog. And so what I did here is I said, okay, for the IKEA, these were the information that was on the card, whether it was what kennel, the change for the different kennels, and then the random variation that we'd see that we can't control for. That was done by the random normal command on your calculator. And then the treatment, but right now the treatments aren't randomly assigned. I want to make sure that these treatments are all mixed up and randomly assigned to these 6 IKEA dogs. I don't think I spelled that right, but anyhow, let's take a look at this. So I did the scramble attribute values, and here we can see they're scrambled, and we can see I've created a formula called total. -105 is what we'd expect to see typically for any dog in general, -2 for this particular breed of dog, and then we see the change for kennel, other, and the change based on the treatment. And then I calculated the change, and this is where we went wrong in class last week. What we needed to do is actually take the value that we got for the total and subtract it from the average value for these 6 values to see how it compared just within this dog. So I took a look then at these values and said, well, let's do the same thing with the other types of dogs. So I did this essentially the same thing for each of the dogs, where I randomly assigned them a treatment. So notice there's 2 of each treatment here. Same thing here for the Beagle. They were randomly assigned, and there's 2 of each treatment. And once again, the total is calculated. The total bone density change is calculated by starting with the average change we'd expect to see for any dog. On average, the bone density change is -105. The +9 is for the Beagle. Beagles actually don't lose as much bone density. They actually gain bone density as they get older, I guess, +9. Then we have the other random variation that we can't control, the variation due to kennel, and the variation due to the treatment. And then once again, I calculated the change by comparing the total with the mean within this this breed of dog. And so I did that for each of the 4 dogs, and then I had to actually, there was no easy way to do this in Fathom, take the data and just transfer it over. So for example here, you can see that I just took the numbers and just typed them over here, and also took into account, taking into account the type of treatment, exercise, control, calcium, and so on. So I did that for all 24 dogs, and that's what we would have done in class. And then I decided to graph them, and so I graphed the change. So I graphed the change based on each treatment. That's what we have going on down here. And when we do this, we can see that there's a difference. This difference was hidden when we did the complete randomized design. So the breed of dog makes a difference. Calcium might be okay. It doesn't always help the dog, but clearly exercise is the way to go. And no matter what breed of dog you have, exercise seems to matter. So what about blocking by clinic? Well, I did the same thing, complete randomized design. We can see there's looks like there's no difference in that control. The exercise or calcium doesn't help. But then when I blocked by clinic, I did the same exact thing, and I blocked by clinic and looked at the change based on the clinic. That when we looked at the clinics, we can see that exercise helps, even if we block by clinic. So that's technically what should have happened when we did the dog blocking exercise in class last week.